Good morning, everyone. Nice to see you all here. My name is Breistøl, and together with my team, we flew in from Norway to tell you some cool things that we've done on our side. First off, my name is, as I said, Breistøl. I've worked for about 10 years with the data. Started off as a geophysicist, found out that searching for oil and gas wasn't hard enough, so I started doing data infrastructure instead. Sometimes I regret that, but mostly I don't. What I'll try to show you today is a lot of cool things. First, I'll provide some context for this talk. I'll talk about the structure of our organization and our business and why that calls for automation through infrastructure as a code. I'll talk a bit about how we deliver platform as a service to the Alliance. I'll then briefly touch upon how we went from dbt core to dbt platform. And I'll discuss a bit what the value we are realizing using dbt. But first, just kind of a comment. The kind of presentation, the aim for this goal, the goal for this presentation is that some of you will be inspired to how you can solve this in a cool way. I'll not show too much code here today. Our session managers told me no Terraform before 12 o'clock, so that's nice. I'll avoid that. But there will be at least some cool inspirational stuff. If you want to get into the detail, let's just hook up after the meeting, and I'll set up a talk. First off, SpareBank 1 is what we call an alliance. It's an alliance consisting of a set of independent banks and financial product companies that operate both in the private and corporate markets in Norway. This is a bit of a peculiar setup because these companies actually compete commercially. They are competitors. They try to get the same customers, but they cooperate on a few things in order to further compete in the market against other vendors outside of the alliance. So they collaborate on branding, marketing, procurement to get better deals, but also technology and infrastructure in order to try to centralize deliveries. SpareBank 1 Utvikling, it means SpareBank 1 Development, is the company that I work for. We are a key service provider to the Alliance on technology and infrastructure. And we provide a large set of services to the Alliance. This includes mobile and online banking, network and cloud services, but also the data and analytics platform, which I will talk about here today. So just to set the context, what is the context for this talk? What are we actually doing here? First off, just as a reminder, what analytical purposes does data have for a bank? Well, it's mainly three things. Of course, there's a lot of others, but for analytical purposes, you have internal analysis for internal purposes to analyze things related to customer churn or other things related to the customers. You have internal reporting, and you also have regulatory reporting. So there's quite a lot of different stuff that you can do with your analytical use cases. Who are these people who contribute to the data value chain? There's a lot of different personas, but it's the usual ones. It's a data engineer, it's a data scientist, it's business users. Sometimes these personas are one and the same person. Some of these banks are super small and maybe have 2 or 3 people working with the data value chain. Some of the banks in the Alliance are much larger, have maybe 150, 200 people working in this value chain. So that means that when we think about this service, we have to also cater for granular and quite detailed usage patterns. And we also have to cater for some broader usage patterns. How did the banks work before? They came from individual platforms. That means that all of these banks in the Alliance actually came from roughly 2 or 3 different types of platforms that they maintained themselves. Some came from SAS, some came from Microsoft SQL, some came from Oracle. That also meant that each bank actually had to cater for their own technology. They had to maintain it and deliver it to their own organization and the business. Now, instead, they get a platform as a service delivered by us. We're a centralized team, and we deliver this to approximately 150 users, and it's steadily growing by the month. But before we get into the details, I'd just like to stop on kind of what is a platform to me? What do I mean when I say platform as a service? Because essentially most tools in a modern data stack call themselves a platform. dbt is a platform, Snowflake is a platform, everything is a platform nowadays. But when I think of a platform as a service that I deliver to my users, I like to think of a workbench. A workbench that you install in your garage. It has a set of tools that are available for use. You may use some of them, you may use all of them. They should be readily available. It should be easy to pick them up and do whatever you feel like doing with it. It should be safe. It should be somewhat cost efficient. And this is what we try to do when we create the platform as a service. This is what it looks like. We're in the blue box. We deliver a set of platform instances out to the banks at the top. So we do this by delivering a platform as a service to the customers. The way we do it, and that's what this talk will be about, is how we create and provision these platform instances to each of the banks, to each of the entities in the alliance, and ensuring full separation between these platform instances, including the data and the models that are contained with them. For a bank, of course, that's hugely important. There can be no spillover or insights shared unless explicitly granted. What does that mean for the bank? Well, it means, the only thing it actually means is that they have to be the legal owner of their own instance of the platform. If they get a governmental audit or something similar, they have to answer the questions themselves and have to own the instance. They are legally responsible for their own use of it, so they install this workbench in their garage, but it's up to them to be legally responsible for what they create on the platform. That also means that they must take responsibility for their own compliance and cost control. What we can do is to help them do it easy to make it right. We can help them with risk assessments. We can help them do privacy data considerations. We can help them do procurement. But in the end, they have to take responsibility for their own compliance. Here's the stack. It's big. I'm not going to go through all of these details. But you can see the usual suspects here. We have some ETL tools, we have some analytic tools, we have a CI/CD tool stack to help improve the user experience, and we have some infrastructure that is all running on. What I would like to highlight is kind of some of the tools in the stack that I think is for extra interesting in this setting. We use Snowflake for storage and processing. We use AVS as our primary cloud provider on the platform. We use dbt for transformations and lightweight cataloging. We use GitHub for code version control and cross-company collaboration. We use Prefect for orchestrating pipelines. And then we also use something called a cloud-based development environment. We use Gitpod today that provides ready-to-code containerized workspaces. But this is a huge tool stack. And if you go back to the workbench, kind of how do we avoid getting this a reality for the end users? If we were just to open up all of these tools and make them available for the data engineers, it could be quite cumbersome. It could actually be a bit chaotic. Maybe they will wake up in the morning and the workbench wouldn't be readily available. Maybe they have to authenticate in a special way in order to get this up and running. Maybe they had to pre-build some of the stuff before they could even use it. Our job as a platform team is to avoid this reality. So how do we do that? We have created a set of tools around the platform. That platform or that tooling is called DOPE. I tell my managers as for Data Operations Platform Enabler, it really doesn't, but it sounds cool and it's quite easy to type. So we continue to use that. DOPE consists of three main components. It consists of a platform infrastructure as a code. It consists of a dope client CLI and a dope core Python package. The platform IaC. First off, this is, in practice, is actually a set of repos. These repos are owned by us in the platform team, and we use these repos to provision resources, including accounts, to the customers. Specifically, what we do is that for each of the tools in the workbench, we use infrastructure as a code to provision these resources and make them available for the customers. For Snowflake, that means an account, a set of roles, databases, and security. For AVS, it means an AVS account, roles, S3 buckets, and policies. For Prefect, it means an account and a set of workspaces. And for DBT, you guessed it, an account, projects, permissions, connections, and jobs. This takes away a lot of the complexity and a lot of the hard setup for each of the banks. It also means that we can do this in a standardized way and make this readily available just by our own runs. The infrastructure itself also allows us to create concepts within the platform that can simplify and abstract some of the complexity. It means, for example, that we can say in this workbench analogy that you can have a project that you work on. We can link that project term and terminology to other concepts in the tool that kind of unifies this experience. We can also make DBT macros available for the Alliance through this IaC, and a lot of other cool things that we can package within this. Then we have the client. This is a command line interface that you can run from the terminal. This is also where we can package a lot of really cool things. We can create our own commands. We have, for example, made the dope login, which allows us to propagate the login and authentication across all of these different tools. We have made the dope template that allows you to set up a project, a full project in a standardized way. We've also made available in the CLI some of the underlying infrastructure and tooling commands, like, for example, dope AVS put and get secret that allows you to interact with the secret handling in AVS itself. We also have a Python library called dope core, which we use for programmatic access. These are typically imported into applications and scripts. 99 out of 100 times this is used for ingestion pipeline config, and it's of course a essential piece in order to get all of this other stuff to actually work. So, DBT, why are we here? Well, a couple of years ago, we started our journey with this tooling and tried to set up a design for what the platform would look like. And we started off, as many did, with DBT core. And in the next couple of slides, I'll talk a bit about that journey, what we initially did, how we delivered that DBT as a part of the platform, why we wanted to go for DBT platform, and what that migration journey looked like. And hopefully it can motivate some of you in the crowd in order to get on with that journey and do some cool stuff along the way. So what do we have to maintain with DBT core? So from about mid-2023 to early this year, we included DBT core in the platform. What we did was that we wanted to cater for this experience in a lightweight way, and in order to make this experience as easy and nice as possible. We pre-installed DBT packages on our Gitpod image. We wrapped the DBT commands within the dope CLI in order to improve the developer experience. We ensured integration between Snowflake and the DBT project in order to streamline that. We created a set of templates that orchestrate DBT jobs using Prefect, our orchestrating tool. And we also enabled the Loom in the dope in order to cater for multi-project iteration and reference. And this all worked. We were actually able to get a really good user experience out of this. So no shame on DBT Core at all for that. What this shows is actually it's possible. You can do it, it works, and it can actually create a really nice user experience. The problem is, of course, that this is quite a lot to handle. And not only that, but with us being the main caterer for DBT Core, it also means that not only do we have to maintain this work, but we also have to answer any support questions and help people with that setup. So what was the motivation to go full platform? It was kind of two-way divided. There was some things that we were struggling with, or things that was painful, and there were some things that attracted us to DBT platform. First of all, scheduling and orchestrating DBT jobs in Prefect was a high threshold for quite a few people. If you're not fluent in Python, if you're not working day-to-day with Python-based code, this was a bit of a barrier for quite a lot of people. In addition, with DBT Core, you have to be opinionated on your versioning and your Git integration. And this became quite complex for a lot of people, and it also meant that we had to set some guardrails around the projects. On the more attractive stuff, of course, DBT catalog was something a lot of users told us that they was interested in getting to. They wanted to see lineage, they wanted to see documentation of models in an easy way. The second point was the one that I mentioned earlier, SLA and support. Many of the users, but maybe even more, their managers wanted some sort of SLA and support deal that ensured that they could get 24/7 support on anything related to DBT. Lastly, some of the users in the Alliance wanted a GUI-based workflows to enable data democratization. That means that some of the users and some of the managers in the Alliance wanted a easy to look and feel interface that they could work with DBT. Nice. So, in this slide, I'll talk about how we do run DBT today and how we enabled fast migration. So, earlier this year, we started using DBT Cloud, and it was a huge success. Today, the main part of what we do and what we need to do as a platform team is actually just one thing, and that is to provision the accounts to the platform instances and set up these resources that I mentioned earlier. One bank gets one account holds several projects. That's it. Today, we are about 130 DBT users, about 135 DBT projects. We have roughly 13,000 models, and we are on our way to completing the first project to Fusion. And this works very nicely. We're super happy. We get great feedbacks from our end users. But there was, of course, a lot of concerns during the migration from core to cloud. How can you ensure that this will be actually stable for us? How can we ensure that this will not disrupt the business? So we made we planned quite a bit. We did some technical preparation. And here's a few tips on how you can ensure that that can also be smooth for you. So what we did was actually we created a set of infrastructure as a code modules. We use OpenTofu, which is a Terraform fork, but you can also use Terraform if that fits your organization. In these OpenTofu modules, we did two things. We enabled integration to the rest of the platform through resource bootstrapping, and that allowed us to kind of cater for this migration instant. The second thing that we did was to create an optional part where we created DBT jobs as a code from the Python config that was sitting in core. And this simplified the migration a lot. It means that some of the banks that wouldn't do this manual rewriting could just use this OpenTofu models to actually migrate to DBT jobs. But don't just take my word for it. Here's some stats from the migration that we actually did. This is SpareBank in Sør-Norge. It's the biggest bank in the Alliance. It's the second largest bank in Norway. We migrated 70 projects in one weekend with 0 downtime together with them. What it looked like, super easy. The infrastructure as a code spun up all resources on Friday after work. The banks executed the models throughout Saturday, clicking through them. They QC'd on Sunday, and by Monday morning, the migration was complete. A huge success both for the end users, but also for the managers who could finally be relieved of this migration ghost that was hanging over them. So, what value are we seeing? What's the outcome here? How did we feel that this is worth the money? Well, first off, simple onboarding of new users is a reality. It means that DBT Core can cater for DBT Cloud can cater for much easier onboarding and much lower threshold. You don't need to be that programmatically capable in order to actually work with DBT, which means that more users can engage in data modeling and data analytics. For even business users that are even further from the data stack, read-only licenses allows quite a nice short feedback loop for the business users. It means that they can go in, they can read the documentation of the models, they can see the lineage, and actually trust the data in a nice way. What this means is increased business output. It means that they can work faster, more efficiently, spend less time on onboarding, and more time actually delivering value to their core functions. The other one is that we see a great reduce in the use of an external orchestrating tool. Prefect works very nicely. It serves the job a lot for other purposes now, but DBT jobs can now orchestrate 80% of our transformation pipelines. It's really good. It also means that we have less demand for an external scheduling tool, and we can reduce that cost for the banks. It also means that you don't have to be Python fluent in order to actually orchestrate a DBT jobs. You don't have to be dependent on other people doing that Python writing if you wrote a DBT job yourself. And last, we as a platform team have deprecated a lot of internal code. All of the stuff around DBT Core that we had to maintain, we can now delete from our repos. We can spend time on other stuff. We don't have to pay that much attention to the changes in the DBT Core repos, and we can actually do other stuff that is more valuable for the end users. In addition, we spend far less time on internal support inquiries. We used to maybe do 4 to 6 hours every week on support for DBT Cloud. Now we spend much less because the support inquiries go directly to DBT instead. And that means eventually reduced cost for the platform team, and then again reduced cost for the banks who actually pay for us. So what's the outcome? How does this look like? What it actually means that our end users feel that they have superpowers. They come to a clear and ready workbench, and they can spend most of their time doing value for the business instead of creating and maintaining difficult infrastructure tools. That's my talk. I'm very interested in hearing some questions. We're also open for discussions off the stage later if there's any interest. But thank you for attending. Yes, any questions? Yes, red dress. I'm sorry, I didn't catch the question.
DBT jobs as code from Python config in code.
Yes.
Can you please give more detail on it?
Let's talk after the talk. I think it's a bit detailed for answer here. Yeah, white PK.
So you're mentioning that you're fitting directly via the job scheduling, right? So how do you ensure that there's like a dependency on the extract and load? So, because usually you just like wait for the load to finish and then you orchestrate transformation. So how do you handle this?
Alan, do you want to take a quick stab at it?
Yeah, we still use Prefect. So Prefect is pretty much
kicking off all the DT jobs.
Oh,
So
okay,
after the ingestion handled by Prefect, and it's basically just kicking off a lot of jobs in DBT.
Oh, okay, so it's sort of like the daily scheduling of DBT Cloud, that you're just creating jobs that are externally triggered.
Yeah.
Right, okay. Nice.
And then just propagates them.
Nice. Black T-shirt.
Yes, I mean, since you mentioned that one of the reasons for migrating to the platform as well was some of the convoluted training with Prefect.
Yep.
Is there at any point a moment where you had considered other orchestration tools or better integration with Unity? Maybe for example, Breistøl?
Yes and no. When we evaluated the orchestration tools a couple of years ago, a lot of these tools were on the table, but we still wanted to keep Prefect because we felt it had the superior advantages on our ingestion pipeline orchestration.
And doing it correctly now that you are using DBT jobs as code in conjunction with Prefect?
If you're referring to DBT jobs as code as the GitHub repository, no, we're using our own Terraform-made module, pretty much. Yes. In short, we're creating our own Terraform-made package.
Yes, blue shirt.
So how did you deal with the need of users to run, for example, ad hoc commands in their environment? So let's say for a figure flash, were they just creating like jobs in the DBT UI?
Sorry, I didn't catch that.
So how do you deal with the need of running ad hoc commands in entire environments in DBT platform? So let's say a figure flash or something.
Yeah, I see.
You have like a custom job for every project?
It depends. It's the short answer. We can discuss it.
We can take it off.
But it's you can do, or we don't limit the users to create things without Terraform. So they can still do whatever they like, but we help them create some sort of template, basically. So the banks can see what the other projects are doing without having access to the project itself, meaning the data.
Yes.
So from a platform team's perspective, is there any part in the IaC component that you guys use to create a general observability around all the projects that are running within the cloud?
We don't use any observability tool as of now. We are piggybacking on some legacy technology that we already have in our organization. As Art knows, it takes time to integrate a new tool in a financial institution. So we are extracting all the logs as an example.
I think the short answer is that we do observability and metric logging, but on a quite simple and most basic scale. Yeah. Yes?
Using your example, like when you create that workbench as a template,
Yeah.
that's used across different clients.
Yes.
Let's say there are 100 clients that already have that workbench. If you add one more tool to the workbench, going forward, other clients will have it. Well, how do you handle adding that tool to everyone else?
We just have to configure it in the IaC. It's just we just have to use the providers available and the interactions that these tools allow us to have. So when we cater for new tools and when we procure new tools, we always have to ensure that they can actually be provisioned and interacted with through infrastructure as a code. So that's kind of a requirement. Yes, red dress.
There's also a bank, and we are right now on the but we want to migrate.
Yep.
What we're doing now is, I want to ask you about how you handle cross-project issues right now.
Cross-project.
So like, we have multiple repositories, multiple projects, each of these, and doing the ref, bringing all these different projects in the package
I understand. Did you catch that, Alan?
I think before we migrated to cloud, we actually created DBT mesh ourselves using S3 buckets and a lot of crazy code. So moving to cloud just helped us getting the observability because then let's say the managers or data owners could see public models much clearer. But I think we can discuss it in more detail later on.
Okay, I get the time notice here, so we have to wrap it up. But please come forward and have a talk with us. Thank you.